In today's video, we will be looking at double replacement reactions, which have the general form AB plus CD gives AD plus CB. So two compounds combined together to form two new compounds. The objective of today's video will be to predict the products of a double replacement reaction, and it is my hope that you will be able to do this with 100% accuracy. So let's look at an example. In this example, we have potassium iodide, which is a compound, reacting with lead 2 nitrate, which is another compound. So let's see what our products would be. In a double replacement reaction, predicting the products is quite easy. We're going to take the cation from the first compound and combine it with the anion of the second. So we're going to take these two and combine them together on the other side. So a potassium and a nitrate. Now, you'll notice that I did not take this 2. That's because this 2 was used to balance lead 2 nitrate. Nitrate itself is just NO3, so I kept the 3 because it's part of nitrate. However, I left the 2 because it was just used to balance lead 2 nitrate. Now, let's see if this is okay. If you look at the periodic table, you'll see that potassium has a charge of +1, and the polyatomic ion chart will tell you that nitrate has a charge of -1. So, a +1 and a -1 cancel, meaning KNO3 is correct. Now, the second part is going to be the anion of the first compound combining with the cation of the second. So we're going to combine these two together on the other side. But when we do this, we always put the positive ion first and the negative ion second. So we have PBI. Now, we need to look at the charges of lead and iodine. Lead is one of our transition metals, so it has a varying charge, which means we have to look over here to determine what the charge of lead was when it was bonded to nitrate. Well, each nitrate had a charge of -1. And if I had 2 nitrates, that would mean that this lead must cancel out 2 -1 charges, so -1 times 2 is -2, so lead's charge must be +2. And iodine, and we can just look at the periodic table for this, because it is in column 17, it has a charge of -1. So this is not okay as it's currently written, and we need to balance it. So we're going to need 2 iodines to cancel out this lead charge. So we're going to move this down here. And remember, we don't actually want the charge in our compound, so it will just look like this, PBI2. Now, we're not done yet. When we're looking at the products of double replacement reactions, we have to go one step further. We need to identify if each of the compounds is soluble or insoluble, and we're going to do that using this solubility chart. So, if we're in this soluble section, that means the compounds will dissolve in water. So they would get an AQ beside them, just like this, if they dissolve in water. However, if they are insoluble, that means they do not dissolve in water, and they would become solid. They would precipitate out of the solution as a solid. And we can read this chart to find out what would happen. There are a few exceptions, as we can see, so we'll look at that as well. Let's take a look at this first one. KNO3 is our first product. So let's see if we can find KNO3. Now, we're not going to find KNO3 exactly. However, we do find under soluble compounds nitrates, so anything that's combined with an NO3. We see over here that there are no exceptions to this rule. So if we have a nitrate present, that means the compound will be soluble, and we would therefore need to put an AQ after the compound, just like this. Okay, now let's look at PBI2. For PBI2, Again, we're going to be looking at this negative ion. So let's find where the negative I would be, or that iodine ion would be. Again, I see that listed under soluble halides. We have I right here. However, this one has 3 exceptions by it. A halide, so iodine, is normally going to be soluble unless it's bonded to Ag, mercury, or Pb. Well, if we take a look at our product, we can see it is bonded to Pb, which means this is an exception. So normally this would dissolve in water and we would label it AQ. However, since it's bonded to Pb, and that Pb had a charge of +2, as we determined earlier, this is no longer going to be soluble and it will be insoluble. So if it meets the exception, we're just going to flip what it would normally be. So if it's normally soluble, but it meets the exception, that means it's insoluble. So we would have to put an S after it. The S stands for solid. That means it will precipitate out of solution. So PbI2 would be a solid. Finally, we have one last step. We need to balance this equation. And to do that, we're just going to add a 2 right here and a 2 right here. So our final answer would look like this. Thanks for watching.